Hi everyone,
Hello. Yes.
this is
Hello.
Partha Sarathi Samal, Quality Engineering Manager at Paramount. So I have joined here for a session and would love to share my experiences and would love to know you as well. Purnima, you want to add anything?
Yes, Parth, definitely. Thank you so much for joining into this session with us. I would like to introduce you to the audience who are watching us. And let me just tell you that we're heading into a very special and intriguing session that takes the conversation around AI in testing a step further. Welcome, ladies and gentlemen, to Spartan Summit by Test New AI. I am Purnima, Senior Marketing Specialist, and it is a pleasure to be hosting this session. Many teams today are experimenting with AI to generate tests or assist engineers. But what if testing systems go beyond assistance and operate as an intelligent, self updating quality system? To explore this idea, we are joined by someone with nearly 2 decades of experience building scalable quality engineering practices across complex platforms. Please welcome Parth Sarathi Samal, Quality Engineering Manager at Paramount. Parth has led automation teams across web, mobile, APIs, connected TV, and streaming platforms, helping organizations improve release confidence and accelerate feedback loops. Alongside his work in automation architecture, Parth is also deeply involved in exploring practical applications of AI and machine learning in testing, focusing on intelligent tooling, agent assisted analysis, and systems that reduce manual triage while improving signal quality. In his session, Agentic AI for Testing, a self updating quality system that writes, runs, explains, and governs test, Parth will be walking us through how agentic systems can transform testing from static regression suites into a continuously learning quality system that detects change, generates coverage, and explains failure with evidence. Before we begin, feel free to support the session using the emojis that you see below. Share your thoughts in the chat and post your questions in the Q&A section so we can discuss them later. And if you discover useful insights during the talk, do not forget to share them with your network using hashtag Spartans and Spartan Summit. Parth, the stage is yours.
Thank you, Purnima, for the warm introduction. Hello, friends. So I know quite a few of us might be aware about agentic AI for testing. However, I would like to emphasize on its effective usage. The core idea is simple. Most AI in testing today helps with isolated tasks. It writes a test, it suggests an assertion, it summarizes a failure. Those are useful features, but they do not solve real enterprise problem. The real problem is releasing confidence. When a release is about to go, the leaders do not want a pile of tests, they want a clear answer. What changed? What risk did that change create? What validation ran? What failed? What evidence supports the release decision? So, this presentation is about a self updating quality system that does all of that as a single closed loop. It watches change, it selects validation based on the risk, it executes, it explains the failures, it enforces policy, and it keeps learning from production signals. The key shift is this. So, we stop thinking
Uh,
of,
Excuse me, sorry to interrupt, Parth. I think the slides that you're presenting are not visible. Uh,
okay, sorry.
no
Is it
problem.
visible now?
It's not
Okay,
yet visible. Yes,
my bad.
no problem.
Uh,
It is visible now. Yes.
Probably the full screen is not working. Sorry, guys. So, this presentation is about that self updating system that does all of that in one closed loop. It watches change, it selects the validation based on the risk, it executes, it explains the failure, and it enforces the policy and it keeps learning from the production signals. So the key shift, what we are talking here, is basically we stop thinking of AI as a test writing assistant. We start thinking of it as more of a on-site or on-premise quality engineer with structure, policy, evidence, and accountability. So why current AI tools do not answer the release question? Let's start with the gap. So current AI tools are good at local help. They generate a test script, they summarize defect, they suggest a fix, but they usually work one task at a time in isolation. So that means they do not answer the most important release question: what is the unknown risk created by today's change? That unknown risk is where the outages happen. Say, for example, a pull request change one service, an API contract shifts, a requirement change happens because of a user story, and then the organization still runs the same regression suit, hoping coverage equals confidence. It does not. Leadership leads an answer in under 30 seconds. If, say, for example, a VP of engineering or any leadership asks, is this release safe and why? The system should answer with evidence, not opinions. So, this is not about generating more tests faster, it is about producing trustworthy release intelligence. That is the bar of enterprise grade quality. Fast answers, risk based validation, evidence based release decisions. So, as we move from reactive test generation to an autonomous quality loop, we see that instead of waiting for humans to notice risk and manually trigger testing, we built an autonomous loop. The loop watches for change, it learns from production, it plans risk based coverage, it executes validations, it explains failures, and it governs release outcomes with policy. Each part matters. So, watching means system listens to pull requests, requirement changes, and API spec changes. Planning means it picks the right test based on risk, budget, and impact. Execution here means validations across the right layers.
Uh,
Explaining means,
Apologies, Parth. I'm so sorry. The screen went off.
okay,
We can't see a screen anymore.
I'm not sure what's the problem. Let me share it again. Can you see now?
Yes. Can we also put it on the full screen mode?
I did, probably that caused it to. Is it being shared now?
Yes, yes. We can see it now.
Okay, my apologies again. I don't know. Maybe there is a little bit glitchy connection.
No problem. No problem. Thank you so
Okay,
much. Yes.
no, no
Please.
worries. Yeah, I was explaining means it does. So we are done with execution. Now we are talking about the explaining, where it means it doesn't stop at a red or green. It tells you why something failed. So governing means the system enforces release rules consistently, and then learning. Here it means the production incidents improve the next validation cycle. This is why I call it a always on-site ready quality engineer. It is not a chatbot sitting on the side waiting for prompts. It is part of the delivery loop itself. That difference is critical. The reactive tools help people do the work, and the autonomous loops improve how the system decides. Now, the continuous quality loop triggered by a single change. Most of us are aware of this kind of nomenclature, what happens, because we are all in the quality engineering space. Now, let's make that concrete. Like, imagine a single product change. It may come in form of a PR or a story or an API spec change. That one event enters the quality loop. First, change intelligence interprets what changed. Then the coverage orchestration decides what validation is needed. Then we have the verification and evidence, which runs the validations. Then we have the failure narratives, which explains what happened if something breaks. Then we finally have the quality gates, which apply the policy to decide whether it's a pass, a fail, or a warn. So then we have all that which feeds into the quality console and a self updating graph. The important message here, which I'm trying to convey, is that one change starts one loop and produces one evidence pack. That is a clean model for scale. Teams do not want 10 disconnected tools all giving partial answers. They want one coordinated flow per meaningful change. There are 5 agents, one loop, one evidence pack per run that gives the traceability from change to decision. And that traceability is the foundation of trust. That's the reason we are working in this industry, of course. So now selecting risk instead of running everything. So one of the biggest waste patterns in QA, to my knowledge, is running everything because we do not know what matters most. This particular slide addresses that directly. So the first agent, change intelligence, reads the PR differences, then the requirements agent and the API changes, and it turns those into risk scored change events. The second agent, the coverage orchestration, takes those events and maps them against a living graph. Then it selects candidate tests under budget constraints. This is important because budget constraints are real, runtime is real, and we have limited runtime at times, right? We have to run it overnight or maybe a particular time frame within which we have to complete. So infrastructure is limited. We have Jenkins job, or you can say the infrastructure wherever we are running. I'm just talking about cloud. It could be anything, right? We have already budgeted for that. We can't go out of our budget because we have a sudden delivery happening tomorrow. So we have to stay within the limits. So the release windows are also limited. We have a particular release window. It could be a weekly, it could be a monthly, whatever. But there are some ad hoc releases which happen. So those are constrained. We are constrained within that limits, right? So the answer is cannot be what we think. Like we can't run all the tests, right? So run everything is not an ideal strategy here. It is often a sign the system does not understand the impact. So what does a smarter system do instead? It chooses which services change, which users' journey is dependent on them, which contracts shifted, which tests have strong evidence value, which validations fit the time budget. That is how you move from test volume to decision quality. The best quality systems are selective, not random. They spend validation time where releases are at highest risk. So now executing validations and compiling immutable evidences. So once the system selects what to run, the execution begins. But the execution alone is not enough. Every run must produce an immutable evidence pack. And that pack includes logs, screenshots, traces, network summaries, checksums, execution metadata. In other words, enough proof to support the release decision and enough detail to explain a failure at a later stage. So, this matters because too many organizations treat test results like an opinion. A test passed, a test failed.
Your screen went off again. I'm sorry.
I'm not sure what's happening.
I think it's some network glitch that's happening again and again.
Hmm. Okay, let me share the particular window and see if it helps. Um, can you guys see it now?
Yes, it's visible. Only if you could switch to the full screen mode.
I turned the full screen. Can you see the full screen mode?
Not yet.
Okay. How about now?
No.
Let me do it again.
Can see the slides, but not the full screen.
Hi, Parth. I think there is a platform issue. If you're sharing a window and clicking on full screen, then you have to share that particular window.
Yeah, I'm doing the entire screen actually.
Okay, perfect.
Is it better now?
Yep, it's perfect.
Okay.
Yes.
No worries.
Thank you so much. Sorry for interrupting.
No worries. I was just.
Apologies for the interruptions. Yes. Thank you
That's
so
fine.
much.
That's totally fine. So was talking about like when the test passed and failed, or someone says it's flaky, and then the original context is gone. Right. That's what we were emphasizing on. Now let's see whether a result without evidence is an opinion. That's a question we need to ask ourselves. No, right? So because it breaks trust, and evidence pack, however, fixes it. It turns each validation into an auditable artifact. Now, after all this, you can ask yourself what exactly ran, what build it ran against, with what inputs, what artifacts were captured, and what did the network show, and what trace supports this conclusion. The principle is simple, as I have already illustrated. A result without evidence is just an opinion. So, what we want is reliable AI in testing. Evidence must be the optimum class. So, now explaining the exact cause of failure through causal attribution. So, this is where the system becomes far more useful than a typical test runner. So, most test systems tell you only that something failed, they do not tell us why. This model uses causal attribution. A failed test is mapped directly to the causes, like the production defect or it could be anything. It could be a product related defect, project related defect, or an environment failure or flakiness, right? That mapping includes a confidence score and references to specific evidence artifacts. That is much better operating model for engineers and for leaders. So now the output is not like, say, example, test 481 failed. It becomes this failure is most consistent with a product defect in a changed environment, supported by a trace mismatch and a network error after a contract shift. So this is so much informative, right? Or say, for example, this looks like environmental instability due to a browser grid seen across unrelated suits. Or say, for example, a flaky test which we can't reproduce and there is no correlated code which exists. So these kind of explanations reduce the noise, speeds up the triaging, and prevents bad release calls. So the system explains why it failed, and not only that it failed, just saying that it failed is not much informative, right? So it explains the entire cause of the failure. So this is why we need, and when we are dealing with pressure, we need this kind of system, right? We need clarity, we need cause, and we need evidence which will support our cause. So now enforcing release decisions with deterministic policies, at some point the system must turn evidence into release decisions. This is where deterministic policies come in. The quality gate is a trust boundary. It applies explicit rules such as risk thresholds, confidence thresholds, privacy scan results, reproducibility requirements, and quarantine handling. Then it produces one of few outcomes. It could be a pass, it could be one or fail. So this is important for basically two reasons. First, deterministic policy creates consistency. Teams stop making release decisions based on who is the loudest in the room. Second, it makes AI acceptable in enterprise settings. So leaders do not trust black boxes, they trust policy backed decisions they can inspect. So the policy layer should be visible, reviewable, and versioned. It should tell you exactly why a run passed, won, or failed. This is how you make AI operationally safe, not with vague intelligence claims, but with explicit boundaries. So now, mapping the system behavior through a living coverage graph. In this slide, I'm introducing the most important structural piece, the living coverage graph. So traditional teams think in terms of suits and percentages, but coverage percentages often hide risk, right? So 80% coverage of what? Which service? Which workflow? Which requirement? Which failure mode? A graph gives a better model. You can connect services, tests, requirements, incidents, and production paths. Then you can reason across these relationships. For example, if a service changed, the graph helps identify affected tests. If an incident occurred in production, the graph helps identify missing validations. If a requirement has no strong validation path, the graph exposes that gap. This is why the message here is that coverage is a graph, not a percentage. So, as we can see in this figure, right, we have explained some services, some requirements, and service goals, how it gets interlinked, and how we are addressing that concern. So the graphs let the systems evolve. They also lets you ask better questions, right? What protects this business flow? which validations defend this API, which tests cover this service dependency, and which incidents have no prevention edge yet. So, this is much closer to how real systems behave. Now, we are separating product instability from test instability. One of the fastest way to lose faith in automation is to mix product instability and test instability. When teams label everything as flaky, they hide real defects and weaken the release process. So here I'm explaining basically how we can perform bounded repair, not self healing. That distinction matters. So, self healing sounds attractive, but it often hides change. A selector changes, the tool updates it, the test turns green, but maybe the product behavior changed in a risky way and nobody noticed. Bounded repair is stricter, it allows limited auditable, reversible updates. For example, a safe selector update or weight adjustment with some clear guardrails. At the same time, the system uses causal attribution, which we talked about in the previous slides, and reproducibility checks to separate infrastructure noise from product regressions. So, repair must be transparent and reversible. That means log every repair, constrain allowed repairs, and require repeatability and escalate risky cases. Never silently rewrite reality. This is how to keep the automation trustworthy while still reducing maintenance burdens. Now, securing enterprise trust through repeatability and traceability. Enterprise trust does not come from flashy demos, it comes from repeatability and traceability. If the same input produces different outputs with no explanation, trust collapses. If nobody knows which artifact supports a release, traceability is broken. If evidence is incomplete, audits become painful. That we have already encountered in our career so far. So the system needs strong foundation, version schemas, execution fine prints of fingerprints, so and deterministic replace, artifact provenance, checkpointing, telemetry, and KPIs. So these sound operational, and they are. But this is exactly what moves an AI quality system from concept to production reality. Repeatability means you can replay what happened. Traceability means you can explain why it happened, and together they make a great combo, right? Make the system defensible. So this matters for regulated environments, large scale platforms, and any team that has to answer for any outages which happen later. So enterprise trust comes with repeatability and traceability. Everything else rests on those cornerstones. Now, closing the loop with continuous production learning. So, pre release testing alone is not enough. Real learning happens in production, as we have found out the hard way, right? So, this slide it talks about how the system ingests the production signals like pager duty alerts, sentry events, or Datadog telemetry, right? So, those incidents feed back into the living coverage graph. Then the next execution cycle becomes smarter. For example, if a production incident hits a path with no strong validation edge, the graph would reflect weakness. The next cycle would target it. If a certain class of change repeatedly causes issues, the risk scoring would certainly raise. And then, if certain validations correlate strongly with preventing incidents, they should gain importance. This is how the system improves over time, not by guessing, but by learning from actual failures. And that is a major shift. Most test systems forget quickly, they run, report, and move on. A quality loop should remember, it should adapt. The system learns from production, not only pre release testing. That is where the long term value compounds in itself. So, now moving ahead to the governance of quality through measurable operational metrics. As I have already mentioned, the leaders need visibility, they do not need more vibes. So this slide is more of focusing on operational metrics that makes the quality system measurable. The examples here we are seeing MTTD or mean time to detect, mean time to explain, and coverage confidence, flake rate, selection efficiency, reproducibility, confidence, and escape defect proxy. So what does this metric do? They are more useful than raw pass data. Of course, a pass rate can look healthy while important risk might remain untested. A flake rate can expose test system's weakness or the framework's weakness. So selection efficiency tells you whether your risk model is choosing valuable validations, and mean time to explain shows whether those failures are actionable or noisy. This quality console should show these metrics clearly so that the leaders can monitor system performance, not just the test volume. So this helps QA become an engineering discipline with operational signals, not just a reporting function. So leaders need visibility, not black box output. Now we are integrating the 5 agent system into the existing CI/CD pipeline. One reason initiative like this basically fails because they ask organizations to replace everything. That is not necessary. This architecture is practical because it can sit on top of existing pipelines. You start in observation mode, run it alongside current tests silently, then move to the recommendation mode where it suggests what to run and what policy would say. Then move to the enforcement mode where deterministic gates actively shape that release outcome. The tool chain shown here is realistic. Node.js or service workers for orchestration, Type.js for type for workflows, and then Playwright for browser validation. It could be anything. It could be Selenium, it could be APM, whatever you're using for mobile as well. And AGV for schema and policy validation, and OpenTelemetry for traces and telemetry. The exact stack can vary, as I said, but adoption model is the real message. Not to begin by replacing the pipeline, begin by observing it, then building the confidence, then graduating to enforcement. That makes this implementable in real terms without overhauling the entire value chain, right? But with real constraints. Now, moving from vague confidence to auditable confidence. So before, system like this release language often which sounds like test passed, 5 tests failed, and we think it is safe, right? That is vague confidence. But after building a real agentic quality loop, the language changes. Risk coverage is at a known level. The top changed components were validated. 2 product defects were identified. One warning remains with policy, trace, and evidence. That is auditable confidence, and that is the goal. Not to replace testers, not to add AI to the presentation value. The goal is to give teams a quality system they can trust with human in the loop. The paradigm shifts are real and clear. Agents, not assistants. Evidence, not opinions. Policies, no black boxes. Graphs, not suits. If we build quality system this way, we move from reactive testing to governed evidence-based release intelligence. So, as I have emphasized so far in these slides, I would like to summarize this in one line. It would be this: like a modern quality system would explain release risk with evidence, not report test counts. Thank you, everyone. Welcome to have questions.
Uh, any inconveniences, Parth?
No, I'm done.
All right, all right. Great. So, a huge thanks to you for this insightful and forward looking session. The idea of agentic testing system that continuously detects changes, generates coverage, and explains failures introduces a powerful new way of thinking about quality engineering. So, if we have a few questions, we have a few questions in the question tab. So, if you could please take them.
Okay. We
The
are,
question, the first question is: we're a small startup with limited. Yes, am I audible?
yeah, you're audible, Punima. All good.
All right, all right. So let's get started with the first question. So we're a small startup with limited testing resources. If we wanted to adopt an agent-based testing workflow, what would be the first capability worth building? Change detection, test generation, or automated triage?
Yeah. So you kind of automation triage covers everything. So you have to start with observation, as I said, emphasizing, right? The once you start observing, then the confidence will build, and then after you have built enough confidence, then you can look for the change detection, test generation. Of course, without test generation, you can't look for change detection. There was a baseline you are comparing against with the expected and actual. That's what we have been doing so far in our automation carriers or testing carriers, right? So how do you detect a change? How do you see a deviation? You have to compare it with a baseline, right? So how do you get it baseline? Those baseline serve as purpose for your test generation. So in that order, test generation would come first. Then you look for the change detection which happened, which causes a pass or failure. Based on the failure, you will log a bug and perform the automation triaging with the product owners and their insights.
All right. So I hope Ritu, the question that you asked has been answered, and you've received the right answer to it. The next question is by Bharat. Please share if you took AI agents to production at scale in an enterprise environment. If so, what is working and what is not working? Any insights would be great about this part.
Yeah, it's a great question. We have seen so many stories where AI agents were taken to production at scale, and what are the drawbacks or recuperations of that. A lot of companies are still recovering, the recent with Amazon or a lot of companies, right? So before, yeah, as with anything, right, you play any sports, say for example, you train, right? You train heavily. Before training, you can't go and hit the pitch, any sport or whatever you play, right? Likewise, here the agents, whatever you train, needs a human in the loop. I would emphasize, they need a human in the loop. So, as strong as your agents might be, they might be learned, but without guidance, they need a teacher. For example, you are the teacher acting there, because it's not that you know everything, but you can guide it to do take the right decisions or choose the right steps. We don't want it to kind of uh, autopilot the production at scale with any pull request, with anything as such, right? We would like to have an enterprise which is kind of controlled by the human. You would say, I would rather say is less best of both worlds. Use that, but in a guided way. As for example, our notebook LM, if you might have used it, it is grounded in the reality of the document which you feed it. It doesn't look for external sources like internet, world wide web. So whatever information you give it, if your organization has matured to that level where you can take to the next level, your agents are, or the more model context protocol, whatever you're using, they're mature enough, then definitely why not. But based on that, but before going out and practicing in the real world, you have to look into lower environments, how it is faring. It could be maybe a stage environment or test environment, and based on consistency of the results, and your it also depends on the test data and other things, right? So there are a lot of ambiguities, or you can say dependencies on that. Based on the particular scenarios, it could change, but my answer to this would be it can be possible, but with added security concerns and all those threats at our and the vicinity of us. So I would be very careful doing it. We haven't actually done it in that scale, but that's something which I think all the organizations striving towards as the agents become more intelligent going forward.
Yes, thank you so much. The next question is from Sonia Kapoor. She says that you mentioned separating flaky tests from product instability using telemetry signals. What kinds of signals have proven most useful in practice?
Yeah. So flaky test can come in different shapes and forms, mostly because of the locators changes, which does impact us. I think most of the and yeah, we have a hard time convincing the developers. Please use accessible some IDs which don't change, or don't changes. If it changes, just inform us, or just don't change it because of no reasoning behind it, right? So those are the flaky tests. The product instability, right? Product instability is how your product behaves, basically, right? That we know, that's more of a uh, production, you can say. It could be any environment we are talking about. say for example there is a crash. I'm just talking about higher end issues, right? It could be a app crash, or maybe the application behaving or throwing up issues 404 in API. It could be in the domain as whatever you're working on. So those kind of issues are product instability, right? So you know for sure, right, what is a product, and flaky tests are controlled within your test framework. You control the test flaky test. You know for sure what are the flaky tests, because as of now, I think our logs or screenshot, whatever you have, it gives clear cut messaging which says it failed because of any locator or a similar kind of issue. Not saying exactly locator, but similar kind of issues which cause the test to fail. This is in our control. You can control it. But flaky tests are definitely distinguishable from an application related issue, because application related issue is a bug, right, which you are going to log and probably assign to a developer to work on. So that is a clear distinction. So the signals which we'll have, as I said, in a graph-based form, where we are tracing, just having pass and fail is not enough. The graph would show clearly based on the logs of the telemetry that why exactly and where exactly it failed. So that from there you can easily trace it. But as I think, based on more of your experience, or as a subject matter or as a quality engineer, you can definitely make out whether it's a product instability or a flaky test. But the telemetry, it could be anything. I am not sure what exactly you're using in your company. It could be Datadog, it could be New Relic, it could be maybe Splunk or anything. Based on those traces, you can see exactly where it failed, and based on that, the diagnosis can happen. It could happen any place or any way you want, but there are different ways to tackle it. But yeah, that's my short answer to that.
Thank you so much. The next question says, could you please share an example where system behavior mapping with test coverage
Okay.
is applicable? Yes.
Yeah. So system behavior and test coverage, that's a good question again. So as we're moving towards, earlier we started, definitely people started with requirements waterfall model. We had a clear cut requirements, we worked on that. Then we started with behavioral driven acceptance to criteria and stuff like that. Then we have test driven development and acceptance test driven development. Now with specification driven development, I think most of the LLMs which are at play now, they use specification or create MD files based on that how the system will behave or actually can behave, right? So using that, the system's behavior as such which could happen, or you are you as for sure know, right, how the system will behave, because there are set of instructions which you have been given that the system will behave based on that. But you document that and you break it into chunks, right? It can't be that one single chunk will have the entire coverage end to end flow. That may or may not be possible in such circumstances, right? You break it down into, say for example, a unit test. That test coverage has a broader segment, right? It is at unit test level, integration test level, system test level, end to end test coverage. So there are different segments to it. So you try to ensure that you catch whatever, because goal of any test coverage is solely to find defects early as possible, because there's where the costs are reduced, right? And the unit testing, I'm talking not only for functionality but from API side also, right? You ensure that the API tests not only test those 200 okay or whatever failures as such, but they do a schema validation as well, and also ensure that you do some negative testing around it, and also database, whatever is possible in your jurisdiction, you are able to perform those kind of tests. So my answer to this will be based on how your system behaves backend, front end, and handshake between backend and front end, along with the database is related. So you do at a lower level at unit, start with a unit testing level, and then move towards integration level. If you are able to get those details from the developers, nothing like it, because that helps or saves a lot of time, and you can reuse those components as we are maturing towards more of a developer friendly, or you can say SDET roles or quality engineering roles. You can use that towards your system test or end to end test, where you emphasize, as we know, the quality triangle, we all of us know, right? 70% of the test could be lower level test unit or something. So we focus on that. Based on that, we emphasize that we have covered, not, we can't guarantee 100% coverage. That is a kind of, yeah, overwhelming. But once we have look at the components we have covered, we can see that we connect all the dots or the check marks saying that the product has all these components, and are all of those components tested at lower level, higher level, and end to end. So that's the goal. I would say moving from development, or how you can say unit test level, towards system test level, and ensuring that the regression tests cover all those, and definitely smoke test or whatever you are running for sanity, they also are part of that, which ensures that we have test coverage. And those mapping, how it happens, it can be at a test case level, You can use any tool, test management tool. You can map those test cases with those requirements. It could be in user story form, any form you want, but those test cases you can directly map, and when the test run, they will ensure that those test cases pass, and ultimately they will show up in the dashboard.
Great, Pat. Thank you so much. We're taking the last question for the day by Jane. In large platforms where dozens of services evolve independently, how would your coverage graph stay accurate when dependencies and APIs change frequently?
Could you repeat? I'm seeing a different question on the board actually.
Apologies.
I'm seeing a different question on the board. Could you please repeat, Punima? I didn't catch that question.
All right, all right. The question says, in large platforms where dozens of services evolve independently, how would your coverage graph stay accurate when dependencies and APIs change frequently?
Yeah, change is the nature of our game nowadays, right? Everything changes. So we are talking about large systems that is production ready, I believe, or has been in production, or we are talking about greenfield application. That's a different thing altogether, because there is a, if you talk about legacy applications, if you're talking about new applications, greenfield applications, both behave differently under different paradigms. So when we are talking about a large system, a large system by itself consumes a lot of APIs, as I said, about the backend, and it uses a database or something which goes in the backdrop of it, and the front end also. The front end could also be a mix of it, right? And since we're talking about large system, it could support web, mobile, or any other platforms, right? We need to factor on all those components also. So when there are we are talking about dozens of services, right? It could be microservices. We can't have a monolithic, of course. It has to be microservices we are looking at, because that's how we kind of ensure that the components and all everything stay segmented. And before the prior question which I answered regarding the coverage graph, right? The coverage graph by itself will look at all those unit tests, or you can say the lower level test, whatever we are covering, and ensure that they are tested thoroughly. And there is a way of doing unit test as well. As I'm not here to uh, means talk about how it has to be done, but in an effective and optimal way, if we do, then we can arrest those minor defects which are technical glitches which we can catch. So those unit tests, they have a coverage of their own. Along with that, we have the integration test and the system, or you can say the automation test coverage, which we do, right, based on the functionality. So how do we map that functionality? So those changing requirements, as you're saying, how does that come? That comes from user stories. Basically, you could have an epic where the product owners formulate their thought process and create an epic, and you pick up prioritize user stories and start working on it. You could work within a sprint, or start working towards means I don't know the nomenclature in which you work. It could be a safe based model, it could be a scrum model, but I would just assume it's a scrum based model, where you have dozens of services which are evolving and the APIs are changing frequently. But even though the APIs are changing frequently, you must have a baseline, right? Means there is a method to this madness, I would say, rather, right? So you know what is the expected API. So even though the APIs keep on changing, right? The APIs, you are sure that there is a certain behavior expected out of that. So behavioral concerns, maybe the API endpoints are changing for sure. That's the that's the requirement from the company, or you can say whatever they need. So based on that, you can create mock services. You can also try to create a skeleton of that before. Say for example, you are pair programming with a developer, and developer started developing his API and you started working with him. You don't have the endpoint yet, but your framework, if you have matured it to that level, is capable enough of handling that, and you can start creating your API test and use mocking services, which gives you kind of you can say data which you can always change the API endpoints. Say for example, the 10-day sprint, you will get it at a 6th or 7th day. You can change those endpoints and make it work. You can use test driven development, you can fail it till you get the right data. So that those are different ways you can tackle it. But definitely there is a way when you are seeing the changing APIs, and that then you can I would say simulate that kind of behavior within your ecosystems. And then when you have that, at some point it will be available, right? I know it has changed, but at some point it will be stable and it will be available to you. Once it is available, you can pinpoint to that endpoint, either through any tool you're using, like a Postman or Rest Assured, any kind of tool you're using, and then run your test based on that and see your responses match to that. And based on that, we can see the coverage as we know. Like, we have an API with a, say for example, any functionality, login functionality has set of 10 API. I don't think they will change, but there are certain other, if there are 1,000 APIs, maybe 400 or 500 of them, just few stable APIs will definitely be there, like login or core functionality. The core functionality, using that, you will reuse those core functionality by calling or chaining them and trying to reuse the most of the aspects. Yeah. So based on the, I would say, understanding what changed and mocking those services initially till you get the real data, and then chaining them and ensuring that you get a proper coverage. As I said, coverage comes from unit level or the initial component level or the API endpoint level. Whatever you have a baseline you're comparing against, you need to be able to kind of determine the fate of the API based on that results. So yeah.
Yes. That's all for the session. Agentic AI for testing, a self-updating quality system that writes, runs, explains, and governs tests by Partha Sarathi Samal. Thank you again, Parth, for sharing your insights with us today and for engaging with the audience. And thanks to the audience for joining us.
Yeah, anyone wants, they can reach out to my LinkedIn as well. You can share it here so that anyone has any specific questions, I can definitely answer them or take it up later on.
Absolutely. So you can reach out to Parth with any questions on LinkedIn, and he will be happy to help you all with your queries. And you can also reach out to us on Test New AI community for for getting help about AI, agentic AI, and other things. Thank you so much, everyone.
Bye.